After watching this video lecture, students are going to recognize the contributions of Mendeleev as well as Moseley. You'll be able to understand and interpret how an element's information and location on the periodic table are kind of synonymous, and you'll be able to use the periodic table to identify elements as either metals, nonmetals, or metalloids. So the periodic table, as elements were being discovered, was starting to be organized by various people. And Dmitri Mendeleev was a Russian scientist, a Russian chemist, and he organized the known elements by increasing atomic mass. And then what he did is he grouped elements with similar properties together on his chart. And at the time, we didn't have quite as many elements discovered. There were only 86 known at the time. And basically there were blanks or pieces missing. Okay, and because of his organization, he was able to see that, hey, there's probably some elements that we haven't discovered yet. So he predicted the properties of the undiscovered elements, and basically, 10, 15 years later, all three of the elements that he expected to be present on his table were discovered. Okay, so there was some sort of periodicity or organization to the way that elements are built and organized. And so Mendeleev's organization wasn't really user-friendly, but it was a tool that allowed kind of the organization of known elements to be something that was thought of and put together. Now, it took a British scientist, Henry Moseley. He organized the elements by increasing atomic number, so based on the protons, how we have it organized now. And basically, this organization is what we currently use. It's much more user-friendly, it fits on a nice page, and it resolves some of the discrepancies and difficulties associated with Mendeleev's arrangement. So we have a picture of the periodic table here. We have all the elements. They're organized in Moseley's fashion in terms of increasing atomic number. And basically there are more details or more breakdowns of what this table is representing. Periodic tables are organized in two simple basic arrangements. First of all, we have periods and we have groups. Okay, periods are going to be your horizontal rows along the table. So each one of these rows are a period. Now, in that period, obviously the numerical values that have just been assigned, those correspond to the principal quantum number. So you can figure out, lots of information from your principal quantum number, as we discussed before, and that tells you a lot of information about the elements and their electrons and such in that particular period. Now, your groups are going to be vertical rows, okay? I think more accurately vertical columns, okay? And your groups are going to basically identify families of elements. And you guys are going to be doing some research about various families of elements. But a lot of times similar characteristics like reactivity and such exist in these vertical families or these groups. Now, another component or another organization pattern that you will see is that the periodic table is broken up into blocks. Okay, so the first two groups are going to be the S block. The 10 in between are going to be the D block. The 6 over here are going to be the P block, and then we have the F block. Elements that are in these blocks are going to have electrons, or at least their outermost electrons, occupying that type of orbital. So an element in the S block's outermost electron will be in the S block. Okay, element in the D block, the outermost electron will be in a D, P, and F, etc., etc. Okay, so the information that you are obtaining from just the location on the periodic table is going to be really important for reactivity and other questions that come up in chem. Now, some of you may have been wondering, like, hey, where is this F block coming from? It's kind of disconnected. So the F block, guys, as you saw in the previous slide, is basically pulled out, down and below the S, D, and P blocks. The reason why we do that is because we want it to fit nicely on a piece of paper for printouts and stuff. Okay, but really the F block exists between the S and the D block, and this is why they are referred to as inner transition metals. And we'll talk about that more a little bit later when we do electron configurations. But what I need you guys to understand and know is that that F block that you see on your periodic table is not, some disjointed, disconnected thing from the periodic table. It is actually between the S's and the P's, and we just take it out for simplicity's sake. Now, the periodic table can also be broken down, as we were talking about a little bit before, into various groups. So we have inner transition metals. We talked about that a little bit. The inner transition metals, these are the F block elements. Okay, and we talked about that, but basically we have that delineation. We have main group elements. Okay, and as you can see, this is going to be S and P block. Okay, S and P block. And then we have the D block, okay, which is known as the transition metals or transition elements. Okay, so these are just other ways to referring to particular locations or places on the periodic table. Main group elements are what we're going to talk about most of the time in this class. Sometimes we talk about transition metals. Pretty rarely do we talk about F block elements or the inner transition metals. But your main groups are going to be your S's and your P's. Your transition metals or transition elements are going to be D block, and your inner transition metals or inner transition elements are going to be your F block. Now, periodic table can also be broken down in a little bit more detail. Okay, so we have metals, nonmetals, and metalloids. You guys are going to be researching these. But basically, if you look at the periodic table, you quickly notice that there's a lot of yellow. Okay, so metals comprise the vast majority of the elements that we know of. Okay, but there's also nonmetals, are what you see over here in green, and you have your metalloids. Okay, and we're going to talk, or you guys are going to research the various characteristics. But basically, you have these three different types of elements. It's going to be important for you to know and be able to identify which ones are which. And that'll be important for bonding and such. Something I do want to point out, you guys are going to have to be coloring periodic tables and stuff later. So when you guys are coloring your metalloids, please make sure you include all 8 of these elements. These are the 8 metalloids. And this will be good for helping you guys identify or delineate the locations of metals and nonmetals on the periodic table. Okay, and finally, as I said before, the groups on the periodic table usually consist of families with specific reactivity characteristics. And you guys are going to be looking these up and researching them. But basically, you have alkali metals. Okay, alkali metals are going to be group 1, except for hydrogen. Okay, so please make sure you do not include hydrogen in your coloring. Okay, so it is not part of the alkali metals. It's not a metal. Okay, you have the alkaline earth metals in group 2. Okay, and over here on the far right hand side, you have noble gases, and right next to them are halogens. Okay, these are 4 really important groups. They're discussed a lot. They have very clear delineated reactivities and characteristics that help us understand and explain lots of things. So you guys will be looking at these, but please make sure you're able to label them on the table, as well as the others you're asked to in your work today.